normally outward. Okay, you may call it normally outward actually. As usually whenever you draw normal, the normals are inward. As you take a circle, so that's a tangent. Where are you gonna draw the normal? Inside actually, inside. Okay, inside. But minus n क्या बता रही है?
So like
ठीक है?
radial electric field.
Radial direction actually. I mean if it is, we are talking about electric field. So f dot n is how much of f is exiting in the direction, normally outward direction of the n through the boundaries. The more and more divergence you're gonna have inside the region S of the vector field, the more and more f is going to exit through the boundary. Okay, through the boundary normally outward. Okay, this makes complete sense actually. That you have a region, you have a light source within it, or maybe a water source within it. Okay, and there is a divergence of, for example, water is going on. Okay, and then you say that okay, in that region you take a small part, take a छोटा सा chunk ले ले ज़मीन का, and you ask how much of the water is exiting this region actually. Yeah, what is the divergence of f or the divergence of the water within this region? You're gonna say how much of the f is exiting the boundary. Okay, if it is exiting exiting less, that means that there is there is less divergence going on inside it actually. Okay, and if it is exiting more, so we saw this illustration last time actually. The balls are going on all over, and you are taking the different points, and you are asking the question actually that that how much in the neighborhood of that point the f is diverging out. Okay, and we saw that different kind of conclusions, but the divergence theorem is telling you that the divergence that is happening in this region L, the measure of the divergence, the total divergence that is happening in the region S is equal to the f that is exiting through the boundaries normally outward direction.
डाइवर्जेंस की इंफॉर्मेशन लिख नहीं है तो यहाँ पे डाइवर्जेंस जो है ज़्यादा ज़्यादा होगा। जैसे हमारे पास एक ऐसा रीजन है जिसकी बाउंड्रीज जो है वो जहाँ पर डाइवर्जेंस प्रोड्यूस हो रहा है वहाँ से बोलते हैं और रीजन तक
इसका मतलब है कि f would also be very small there actually. The impact of f would be also very small in the far region part. So the less f would be inside the region, there will be less divergence, and hence there would be less f exiting through the boundary. So it's easy. यानी आप ये कह रहे हैं कि ऐसा भी तो हो सकता है ना, just like a sink actually. ये कह रहे हैं the more is जी कहिए क्या कह रहे हैं
सर यहाँ पर हमारे पास डाइवर्जेंस की सेंसिटिविटी कम नहीं हो जाएगी। फॉर एग्जांपल हमारे पास डाइवर्जेंस
तो फिर एग्जिट करने की भी सेंसिटिविटी कम हो जाएगी। तो both things are going down. So what this theorem is telling you, not only going, both will go down or go up, but they'll be precisely equal. Precisely equal. A bit counterintuitive result, but it all makes sense. ठीक है? So let's do an example. Are we happy with the proof? Yes. We have already proved it actually. Okay, so we took f, and so we took the divergence of f in the region S, applied Green theorem. We got a line integral, and then converted this line, that line integral into this integral actually. So mathematically, it's not a difficult thing, but the real thing is to make sense.
ये जो हमने किया JF डॉट T था, जिससे हमने F डॉट JT में लिख दिया, तो बाद हमने माइनस लगाया है। ये सारे
कितना माइनस लगाया?
वहाँ
नहीं, ये माइनस इधर थी ना, ये माइनस इधर थी. So you have this result that JU dot V is same as U minus u dot jvi. So this was the general observation actually, that if u and v are two vectors, okay, then you take j and of u first and then dot product with the d. So it's like a rotate and take dot product. Okay, so rotate u and take dot product is same as that you rotate v and take dot product, but their orientation would be different. Orientation, but the directions would be different actually in both cases. Okay. So let's do some examples based on it. So what is another advantage of doing it? So Stokes theorem was one way to convert roughly the okay. So it's like it has a physical interpretation, but it's also a tool to convert a double integral into a line integral. So this is also a source of converting a double integral, relating the double integral with the line integral. So let me verify this theorem for one particular example. What would be a three-dimensional analog of it? Can you already think in your head? What should be the divergence theorem in three dimension? So instead of a region, you're going to have a volume. Okay? And you're going to say how much of f is diverging in that given volume. You're going to say this would be equal to same as the f that is exiting the boundaries of the volume, which are surfaces now, normally outward. Okay, normally. So what is happening in three dimension? You're going to have that in three dimension and higher dimension as well. Actually. ठीक है? So imagine I have a triangular region. Is this a green region? It is.
Yes, sir.
It is. I can treat this as that, okay, it sits between two lines, so type 1 and type 2. Okay. And let's see, say this is curve 1 and curve 2 and curve 3. Okay. And I have a vector field that is defined in this region or maybe outside region as well. I think we're just interested in this part of the region. So I have a vector field defined everywhere on some part, but it's also defined in this region actually. It also exists in this region. So let's take f. Where is so the f of xy is x square over 1 plus y and minus x log of 1 plus y. ठीक है? And 1. Let's assume that this line is so I have this line is y equal to 0 and y equal to 1. So y equal to 0, y equal to 1. Maybe here I have x equal to 0. So this line is y equal to 1 and y equal to 0. So maybe mathematically it's better that if I make it on plane actually rather than making it directly. So imagine I have this xy plane. Okay, and this point is say 1 0 0 1, and this point is 1 0, and I'm making a triangle out of it. Okay, So what would be the equation of this line?
X equal to 0.
X equal to 0. So what would be the equation of this line?
X is equal to 1.
And this would be
Y is equal to
Y equal to
1.
1. And what would be the equation of this line? X plus y equal to 1. Huh? X plus y equal to 1. ऐसे होगा या कुछ और होगा? हाँ ठीक है. Y equal to 1 minus x, so it has a negative slope. ठीक है? And I'm saying that is x is defined in this region? I don't see a problem. Because no matter what point you take, you always have a vector associated with it. Okay. So what I would like to do, I would like to verify the divergence theorem. In other words, I would like to compute this side and this side as well.
Independently.
Independently. And I want to know, are they equal actually? Okay. So what would be del dot f?
Partial differences in object.
So it's going to be 2x over 1 plus y. And
Minus x.
so this is going to be
Minus x upon.
plus minus x upon 1 plus y. So it's going to be x over 1 plus y. ठीक है?
Yes.
This will be the
Yes, sir.
So if you want to compute a del dot f dx dy in this region, triangular region S, you need to compute, what do you say?
X upon
X upon
1 plus y.
1 plus y
पहले dx बाद में dx.
dx and dy. So for dy I know I'm between 0 and 1, and x,
For x, it is from 0 to
so I can't say, okay, so
0 to 1.
So if I say x, okay. So if I say x is also 0 to 1, then there is a trouble actually.
It will be the square.
Because then it will be a square actually. So I'm not talking about a square, I'm only talking about
0
this.
to x plus y plus.
So x goes from 0 to this line always.
This function, the line equation is
Okay.
Yes.
So I have x equal to 0.
x plus y.
So what is the value of x on this line?
Y is equal to minus x.
So it's 1 minus y. So it's 1 minus y. Not just x, it's 1 minus y. ठीक हो गया?
Yes.
So calculate it. First with respect to y, then with respect to x, and you're gonna get this result. Okay, so I'm not doing all calculation. I just told you that how to formulate this result.
To लगा for.
Okay, so maybe something like that. Line integral would be more interesting actually. Would be more interesting. So I want to compute the curve on the boundary f dot n onto the boundary. Now the boundary is made up of 3 curves actually. I can say it's made up of 3 curves. C1, C2 and C3. So if you want to compute this, you have to compute this on C1, on C2 and on C3. And then add them up. So what would be C1? So what is outward normal direction in case of C1? I don't need to calculate it. So this direction would be, so that's a curve C1, C2 and say C3. So that's the normal inward direction.
But we need outward.
We need outward direction actually. So what should be n?
So same you are gonna x is equal to 0.
Nee. Vector.
अच्छा वेक्टर.
Vector. What vector would represent the direction of the normal outward?
C3. Vector C3.
So minus j.
Minus j. So it should be minus j. Because this is j direction. Moving there, you're moving along j direction. So that's minus j and that's positive j direction. Okay? Minus j direction. And I'm saying let's take f dot n. Okay? F dot n. So what would be f dot n? So this is like you have a 0 minus 1 actually.
Yes, sir.
Yes.
So we have
So f dot n is going to be what? So the first component would be 0, so you're going to get x
log of 1 plus
log of 1 plus 1.
सही है
ठीक है?
इसकी ऊपर से करेंगे
And now integrate it.
so 0 to
Okay, integrate it. So in order to integrate it, what you need. So you have to think carefully. I mean, when you are talking about this, y is fixed here. It's only x is there. So when you are on this curve, x is changing,
minus 6
y is fixed actually. Okay, so what is y here? So you can go, a step ahead actually. So since y is 0, so this log will become 1 plus 0, and whatever x you choose, this is 0. You don't have to do any calculation. Okay? So f dot, let's call this n1. F dot n1 is 0. ठीक है? समझ आ रही है बात? चलिए let's think about C3. Let's call that vector as n2. So n2 goes like this, outward.
minus I
So it's going to be minus I. अब हम होशियार हो चुके हैं. ठीक है? So what would be f dot n2?
ये minus 1 और 0 से
F dot n2. So the n2 in this case is
minus 1
minus I.
minus 1 minus
Okay. So when you're going to multiply this, take the dot product of this with n2. So what you're going to get f dot n2 is,
minus x square over 1 plus 9
so it would be minus x square over
1 plus
1 plus y. So what is the value? So which is changing and what is not
यहाँ
changing?
पे x 0 है तो ये भी 0
So x is 0 है,
तो ये भी 0 है
okay, but y is fixed. So this guy is 0 as well. Okay. Now comes the interesting part. Now this direction is not really
interesting
n3. So this is your curve C3. Okay. So in other words, nothing is exiting through curve C1 and C2 in case of this vector field. Okay. Maybe we can plot it. We're going to see maybe it's going this way actually.
yes
So nothing is exiting here. So it's just exiting in this direction anyway. N3. So tell me how to find N3.
I plus j it's going in both
I plus j.
I plus j.
I is
So is I plus j is a unit vector? Okay, so we are fine up to I plus j. We are fine up to I plus j, but the question is, how can I turn this into a unit vector?
normalize करना.
Normalize करना है. So what should be N3? What should be N3? 1 over square root of half and 1 over square root of half. Okay. Even there is a general recipe. We're not getting into the proof of it. But imagine you have been given a Cartesian equation of a curve. Okay, so I have some wiggly curve actually, and I want to draw a normal vector. Okay, onto it, and I know the equation of it actually. Okay, so I know that this is something like j of xy, maybe g of xy, something like that. Okay, and you want to find the normal. The normal can be computed as simple if you have been given an equation. So if you have been given an equation of a curve and you want to find a normal on it, first of all write it in this form actually, g of xy equal to 0. Write it in this manner. So whatever function comes as an outcome, just compute its gradient and divide it by the magnitude of g. That would always be a normal vector. Just a trick. Requires proof, but for now, not getting into it. Now, so if I say that what would be g in this case actually? So I have an equation x plus y equal to 1. I want to write it in this form. So what should be my g of xy in this case?
X plus y minus 1 equals
So it's going to be x plus y minus 1.
this.
That will be the g. So if you want to compute the gradient, what you need to do? Compute the gradient of the g and divide by the magnitude of the gradient of the g. So what would be the gradient of the g?
So x correct is the 1.
So it's going to be 1.
1 this time.
Okay. And what would be the magnitude of the gradient of g?
1 square, 1 square.
Square root of 2.
Square root of 2.
It's going to be square root of 2. So again 1 over square root of 2 and 1 over square. So that's a general recipe. So in some cases you can guess, in some cases this recipe works actually. Okay. But you can also have that trick actually that I can treat this as I plus j, but we need to normalize it and turn it into a unit vector. So therefore you have to divide it by the magnitude of the vector actually I plus j, which is square root of 2. Okay. ठीक है? So अब कर देंगे compute, not a big deal. So f dot n3.
1 upon root 2 बाहर हो जाएगा.
So 1 over square root of 2.
बाकी x स्क्वायर अपॉन 1 प्लस y स्क्वायर रूट माइनस. ये जो भी है सब मतलब प्लस कर देंगे.
किसको प्लस?
ये जो f के कंपोनेंट है
तो फिर ये
x स्क्वायर अपॉन 1 प्लस
x स्क्वायर ओवर
1 प्लस y
1 plus y minus x log of 1 plus y. ठीक है? And you need to integrate it. 1 over square root of 2. ठीक है? And you have x square over log of. अब यहाँ पर एक problem है. Problem ये है कि there are two variables and I need to do a single integration actually. The question is, y is unnecessary. Think about it. I mean, I can convert y in the terms of the x actually, because on this line I know that y is 1 minus x. So wherever I have y, I can put 1 minus x, and then just directly put the value. So what is okay? So this would be an expression in the terms of the x, where x goes from 0 to 1. That's it. And you compute it, you're going to get precisely this answer. Okay? You get precisely this answer. So I just gave you why I went through this example, because this experience is important, at least for once, that how to do the computations. Okay? समझ आई ये बात? ठीक है? You have to always think. I mean, अगर मैं if I put this directly here, you can ask, should I integrate with respect to what? With respect to x, with respect to y. Or the other way could be that find a parameterization for x plus y equal to 1. So what would be the parameterization for x plus y equal to 1? True.
1 minus.
True. So if I substitute t, what would be y?
1 minus t.
So that's it. That's a parameterization of it. Why it's difficult. So you have a line given 2 points and you can find its parameterization. It's not a big deal. Okay. So wherever you have, this kind of a function y equal to f of x, you can write it in this manner. You can easily find a parameterization. X f of t is the parameterization of it. Okay. Are we happy with it? So what divergence theorem is telling you is what so what Green theorem was telling you, that if you take these microscopic circulations within region, Green region or Jordan region, and add them up, you're going to get a macroscopic circulation actually around the boundary. And what does this theorem is telling you? That if you want to know that how much of this f is spreading, okay, in the given region S, just have a look at how much of f is exiting in the normal direction through the boundary of the given region S. That's it. Take it. It's pretty much natural ideas. What I would like to do next, so we do have some time. So I hope it's not that difficult. Yes, let's do it. दुख में लावा करो. So, what next I would like to do is I'm going to talk about. So see, one of the things that we realize from these two theorems that it's pretty much important to calculate the the double integrals, because you are going to encounter the double integrals again and again. Okay, so if you have a bit complicated region, calculating double integral could be a tricky thing actually. Okay, and the way to deal with it, for example, you are trying to calculate a double integral. Okay, and it turns out to be difficult. So quite often it happens that if you change the order of integration, in other words, instead of integrating with respect to, say, so x first and y, I just integrate y first and then x actually. But you have to be very careful when you are integrating, for example, with respect to y and with respect to x first actually, afterwards, because the limits will change. And quite often people get really stuck in that actually, that how to change the limits actually. Okay? For example, in this example, we had this, this x over 1 plus y, okay, and I have dx dy. So on y I had this limit 0 to 1, and on x I have limit 0 to 1 minus y. Question is, what if I want to do this actually, dx dy? Okay, so for x I know that it goes down 0 to 1, but how about y? So previously I was looking from this perspective. I was starting from x equal to 0 and ending at this line. But now you are looking at from the perspective of the y. So you're going to start from y equal to 0 in this region, and you are ending up at this line actually. So you have to see what is the value of y on this line. 1 minus x. Okay. So fortunately it's easy to deal with this here actually. Okay? It's not always easy. You want to do it. So let me give you a generic recipe, okay, for changing the order of integration, and then do some examples. I'm not going to solve those double integrals. I'm going to just tell you that how to change the order of integration. Okay? So you got some sense of it. I hope that the rest you can also really understand. Okay, so here's the kind of a region, for example. You have it. Okay, something like that. And I'm doing integration here. I'm going to say, okay, this looks like is some y equal to a, and this looks like some y equal to b. While these are the two curves. So this is phi1 of, say, x, and this is phi2 of x actually. And I want to integrate it, some f of x, y with respect to, for example, first of all, what would be the more better way to integrate? Shall I integrate with respect to x first, or it should be x or y?
Y.
मैं तो सो रहा हूँ, तुम भी सो रहे हो, full time. ठीक है? Y होगा, x होगा.
Yes sir, y की वजह से
Type 2 है ये
ठीक है? Question. So if I integrate, shall I integrate first with respect to x and with respect to y? So the better would be if you So on y I have constant limits actually. So on wherever you have constant limits, integrated second time you do it, because I know that on y I have this a to b. Okay. And with respect to x, I know that x goes always within this region from this curve. So always starting from this curve and ending at this curve, starting at this curve and ending at this curve. Actually.